lesson, we'll be looking at orders of magnitude and ratio and proportion. So the focus of the session for today, at the end of the session, you will understand how to round numbers to the nearest whole number, tens, hundred, or thousand, and to one or two decimal places. You will also understand how to read and use scales on maps and plans, and to solve simple ratio and proportion problems. And these topics are taken from the Stage 2 curriculum, 208 and 209. So let's have a little review. What is rounding off? Rounding off is a form of estimating. And I'm sure you all know what estimation is. You know, you're sending someone to the shop, you pretty much estimate how much you're going to give them because we don't check the exact thing. So we round off every day in our real life. So rounding off means making a number simpler, but keeping its value close to what it was. The result is less accurate, but it is much easier to use in calculations. All right? If a digit to the right of the place you are rounding off, just some points to take note of. If the digit to the right of the place you are rounding off to is 5 or greater, you round up by adding 1 to that place that you're rounding off to, and you make all other digits to the right 0. If the digit to the right of the place you're rounding off to is 4 or less, you round down by leaving the place, the digit in that place the same, and make all other digits to the right 0. Now, rounding off to a decimal place. It is important that we understand when we say we're rounding off to 1 decimal place, 2 decimal place. So 1 decimal place, that's the tens place, the number right after the decimal. 2 decimal places is a hundredths place, which is 2 numbers after the decimal. All right. Scale drawing, we'll also be looking at scale drawing today, which shows a real object with an accurate size, either reduced or enlarged. So the first question, the number of people attending a baseball game was 24,658. Let's go again. The number of people attending a baseball game was 24,658. Round this number to the nearest thousand. So we're rounding off. We look at the number. What's the first thing we want to do? What digit is in the thousand place? So we're rounding off to the thousand place. So the 8 is in the ones, the 5, tens, the 6 is in the hundred, and the 4 is in the thousand place. So we have identified the number that we're rounding off to, 4. Now, what digit is to the right of 4? Yes, that's 6. So 6 is to the right of 4. 6 is greater than 5, so we round up. So we're rounding off the 4, that's a thousand place, and we're going to add 1 to that 4, making it 5. So it's now 25,000, because we would have round up and replaced all the other digits to the right of the 4, or the 5 in this case, with zeros. So what we're saying, 24,658 can be rounded off to the nearest thousand as 25,000. Next question. What is the place? But let's read the question first. The number of people watching a television program was 752,658. Round this number to the nearest thousand. So we're still at the thousand. What digit is now in the thousand place? That's what is important. All right, so we identify the 2 is in the thousand place. What digit is to the right of it? 6. 6 is greater than 5. We are going to round up, and the number becomes 753,000. So when we round off 752,658, we get 7,053,000. All right. Next question. 8.46 written correct to 1 decimal place is, now remember what we said. What is a 1 decimal place that we're talking about? We're talking about the number that is in the tens place. So what digit is in the tens place? That's the first place after the decimal, and that would be 4, right? So we look to the right of 4 and we see a 6, right? So it is greater than 5, so we increase 4 by 1 and it becomes 8.5. So 8.46 to 1 decimal place is 8.5. All right, so let's look at this question. 3.416 written correct to 1 decimal place. Same concept, all you need to do is pay attention to the place that you're rounding off to. It's 1 decimal place, that's the 10th place, that's the first place after the decimal. So 3.416, the 4 is in the 10th place, and we look at the 1. What is the value of the digit? It's 1. The 100th place is 1. That means we are rounding down because it is less than 5, so the 4 will remain unchanged, and written in 1 decimal place, it is 3.4. There you go. So that is pretty much it for this section of the lesson. Let us look at the next question. So 2.3672 written to 2 decimal places. What is that number? What does it look like? So what's the first thing? We want to examine the number. So 2.3672. How many decimal places are you seeing in this number? If you said 4, great job. There are 4 decimal places in this number, and you're asked to give the number to the correct to 2 decimal places. So we want to look at what digit is in the 100th place. And the digit 6 is in the 100th place. So we want to look to the right of that digit. To the right of the 6 is a 7. 7 is greater than 5. Therefore, we are going to round up, we're going to increase 6 by 1, so it becomes 3.37. So correct to 2 decimal place, and as you can see, I've put 2DP, so the DP stands for decimal place. So that's what it is. So it's 2.37. All right, so we're at another question. A calculator display shows 17.0679. What is this number written to 2 decimal places? Same concept, you want to identify the digit in the 100th place. So let's go through it. So we know it's 2 decimal places. And what digit is in the 100th place? We identify that it is 6. Excellent. We look to the right of 6, which is 7. And I know you're getting this now because I know you're probably saying I'm giving you so much of the same thing, and you get it now. So the 7 is greater than 5, so what do? Correct, we round up. We add 1 to the digit 6, so we have 1 more in the 10th place, in the 100th place. So it becomes 17.07, and that is to 2 decimal places. All right. So we're at another little section here. The distance between 2 towns is 167 kilometers. Round 167 to the nearest 10. So we've left the decimal, we're back to whole numbers. Let's see what happens here. So we want to identify again what digit is in the 10th place. And that digit would be 6. So 6 is in the 10th place. We look to the right of the 6. We have 7. 7 is greater than 5. So we round the 6 up by 1. The number becomes 170. Remember, when we round up the digit that we're rounding off to, we replace the digits to the right with a 0. And we must keep the integrity of the number. So we're talking about 167. 170 is pretty much close to 167. That is what rounding off tell you. What is the closest value this number is that you're rounding off to? All right, next question. A sales representative traveled 134 kilometers in 1 day. Round 134 to the nearest 10. Same concept, we look for the digit in the 10th place. It is a 3. What digit is to the right of 3? 4. Is it more or less than 5? It is less than 5, so we round down. So the 3 remains unchanged, and we replace the 4 with a 0. The number becomes 130. So what we're saying, 134 round off to the nearest tens is pretty much 130. All right. So on a diagram, 2 centimeter represents 20 meters. Remember we said we're going to do scale drawing, looking at how to read maps. So this is one of the questions that pertains to that part of the curriculum. On a diagram, 2 centimeter represents 20 meters. A line drawn 8 centimeter represents, all right, so we need to look at some of the information that we have here. So 2 centimeter represents 20 centimeter. That's the first thing they tell us. What else can we do? So if 2 represents 20, 1 represents 10. Good. So we know that 1 centimeter represents 10. What does that mean though? It means that for every 1 centimeter that is represented on the diagram, it actually represents 10 meters in actual distance. All right. But they're not really asking you that. They're asking you how much the line drawn for 8 centimeter, how many kilometers would it represent? Well, it's not kilometers. How many meters it would represent? So 8 centimeters would equal 10 meters. For every centimeter, you get 10 meters. And how many centimeters you have? 8. So 8 multiplied by 10 gives us 80 meters. So 8 centimeters represents 80 meters. All right. On a diagram, 2 centimeter represents 1 meter. So the scale can change. So the scale is now different on this particular diagram. So on a diagram, 2 centimeter represents 1 meter. A wall is 3 meters long. Work out the length of a line that represents 3 meters. So what they're saying, now you have an actual length. You have 3 meters. If you were to put that on the drawing, how many centimeters would you use to represent that 3 meters? Let's look at what we can do. So we're scaling it. So 2 centimeter represents 1 meter. 2 centimeter for every 1 meter. So if we have 3 meters, we can then say for every meter you have 2 centimeters. So you're going to multiply that 2 centimeter by the 3 because you have 3 meters and you get 6 centimeters. So on the drawing, 6 centimeter will represent 3 meters. All right? Next question. On a map, 1 centimeter represents 10 kilometers. What is the distance represented by 9 centimeters? So what's the actual distance? Let's look at the information we have. 1 centimeter to 10 kilometers. And we're asked to look at how much 9 centimeter would give us. So we could do it a long way, and we could actually have 9 sets of 10 kilometers and add them, or we could multiply 10 kilometers by 9 to give us 90 kilometers to 9 centimeters. On a map, 10 centimeters represent 20 kilometers. What is the distance represented by 4 centimeters? All right, so let's look at this a little bit. So 10 centimeters for every 20 kilometers. So we know 10 to 20. What can we do here? We can simplify this representation. So since 10 is to 20, what if I factored out 10 out of both of these representations? So now I divide 10 by 10, I would get 1. Divide 20 by 10, I would get 2. So that pretty much simplifying the representation, 1 centimeter to 2 kilometers. They asked me to find out how much 4 centimeter would represent. So if I know 1 is 2 km, I can add 2 kilometers 4 times, or I can multiply 2 kilometers by 4, giving me 8 kilometers. So 4 centimeter will represent 8 kilometers. A lorry driver buys 18 gallons of petrol. He receives 1 free glass for every 5 full gallons. How many free glasses does he receive? Let's look. So now we're looking at ratios. So we have 18 gallons bought, purchased. 5 gallons, you get, for every 5 gallon, you get 1 free glass. All right, so we have a 5 to 1. So 5 gallon, 1 free glass. And we can write it in any of those 2 formats that you see there, with the actual 2 or with a colon. Now, how many sets of 5 can you get from 18 gallons? I know you got this. So you're going to divide 5 into 18, you're going to get 3, and you're going to have 1 extra gallon over there. That's not right. 15. So you're going to have 3 extra gallons, but if you buy 3 gallons, you don't get any glass, so you can't bother look at that. So now we know we have 3 sets of 5 gallons out of the 18 gallons. Okay? So we can use this to influence the ratio. So for 3 multiplied by 5 gives us 15, so that's the 15 gallons, and 3 multiplied by the 1, that's the 3. So for the 15 gallons, you will get 3 free glasses, because for every 5, you get 1. And you would have had 3 sets of 5, so you would have get 3 free glasses. Awesome. A cook uses 4 eggs to make 1 cake. How many eggs would she use to make 3 cakes? All right, so we're still at ratio. 4 eggs to make a cake. Let's write that. So it's an eggs to cake ratio, and that's 4 to 1. So if we increase the number of cakes, the number of eggs will also increase. So we have 3 cakes. We'd have multiplied 1 by 3 to get you 3 cakes. We also must multiply 4 by 3, which will give us 12 eggs. So 12 eggs will be needed to make 3 cakes.